gas fees and in terms of slow network response times. I think we're keen to hear what Algorand can offer. So Julian, I'm going to kind of hand over to you and maybe you introduce yourself. And then I don't know how you want to run it, whether you want to do a Q&A or whether you want to do a short introduction on Algorand. But over to you.
Okay, cool. Thanks, Meryl. So I think I did try to put together a presentation, which we can maybe sort of jump from section to section and not necessarily go through that in a structured format. Hello everyone, my name is Julian Kanjere. I am a PhD student at the University of Cape Town. My research is looking at data privacy and using blockchain to achieve data privacy within the context of banks reporting their risk information to regulator like the central bank. And before the PhD, I've worked as a software developer in financial services and then in a professional services context. And then around about 2018, 2019, started to get more and more into the blockchain space. And I did my fintech master's at UCT. And my thesis project was looking at food traceability using blockchain, which we've actually also carried on beyond the academic side of it. We've turned that into a startup and we're trying to make a difference, I guess, using blockchain. Outside of that, I have last year supported some of Meryl's students, also UCT. They were an honors group that were working on a plastic life cycle management solution, so like a recycling solution, and with sort of tracking bottles from the source producers all the way through to a bottle getting to a consumer, then being recycled but being picked up by a waste picker, and eventually being deposited at a recycling depot. So just tracking that on the blockchain. So helped some of the students there with the questions that they had and just making sure that they were on track. And then I've also provided a bit of support as well for the current MPhil and FinTech students at also UCT. So I've worked with the Ethereum blockchain. More recently, we've started working on the Algorand blockchain. So hopefully I can answer some of the questions that you might have today. But before getting into the session, Meryl, I think just it would help me to get a good feel of where the different groups are at in terms of the research that's been done. So I think one of the groups mentioned that they were looking at Solana. So maybe just to get a bit of a sense of which blockchains have you looked at and what's the thinking behind those blockchains. So the group that said that they've looked into Solana, it would be good to hear what you sort of found out so far and maybe why you've been looking at that specific blockchain.
Hi. So we currently are looking at Solana because it has incredibly low gas fees, and it seems like the transactions per second that it enables are incredibly high. So it's both fast, enables, of course, low gas fees, as I've just mentioned.
Okay.
And ultimately, it seems like it's quite an innovative place where a lot of, especially because, of course, we're doing NFTs, it seems like a place where a lot of NFT startups are using. It seems like, of course, Ethereum's going to always be the main one with OpenSea. But Magic Eden, which is the main secondary marketplace for Solana, seems to have had like a massive uptake. So that's why we've ultimately been looking into it.
Okay.
Yeah.
Okay, cool. Sounds good. And have you gone further than just the initial research? Have you looked at, like what SDKs they offer? Let's say they offer a JavaScript SDK or Python SDK or something.
So we have been doing a lot of research into that. One of our systems analysts is very good at that, so I'm pained that he's not here. But we were looking at also like the integration into the API of Magic Eden, so that we could maybe automatically put the NFTs that get created through our website onto it. And we've also looked at the AWS recognition system to process images to ensure that they like essentially are safe and they're not like an illegal or illicit image. But ultimately, we haven't looked at Algorand. So it definitely is a different avenue to go through. I'm not too familiar with it, but we definitely should look into it. But basically, with our third-year groups, we've taken on the business plan now. So we've completed the business plan, and we now are going into the URS. So of course, that's starting to tackle more of the actual coding-related issues, and I'm going to look at how that will occur or what will unravel.
Okay. Okay. Cool. Sounds good. And the other groups, has any other group looked at any other blockchain platform, and what's the sort of thinking around that?
Hi, so we are the Carbon Credit Project, and we've looked at Tezos blockchain platform.
Okay.
And the reason behind it was the fact that it's a proof of stake platform instead of proof of work. So the energy usage is a bit less. And that was the main reasoning behind it, because being a carbon credit system, we didn't want to be a contributor to the problem of pushing more greenhouse gases into the world. So that was the reason behind going for that platform. We are also not too clued up about Algorand. It's our first time working with the software. We previously were going down the Ethereum route because it seemed like it had the most resources. In terms of where we are in our project, we have a front-end system about 50% of the way done, and we've used C# via Visual Studio to kind of create that.
Okay, cool. Yeah, so that gives me a good sense of you know, where the thinking is and where the headspace is at. I'm just going to quickly share my screen, and then we can have it more as a discussion and not so much as a presentation. Just give me a second to find my window. Okay, hopefully you can see my screen. If someone can just confirm that they can indeed see my screen. Yes,
that's fine.
Yeah.
Okay, cool, perfect. So normally before these sort of presentations, I always like to throw in that this is not any advice in any sense, especially like financial advice, and the views are largely mine, and maybe not so much the views of the university or any other sort of parties I may be affiliated with. I'll share this deck after the session. I sort of split it into two parts, just the blockchain background, and then a second part, which is the Ethereum and sort of Algorand ecosystems. I'm not going to spend too much time on the blockchain background, except that I think the way that I like to look at blockchain is primarily transactional. So you want to exchange value, value typically denominated, either as a crypto asset or as a stable coin, in the future, possibly as a CB, as a central bank currency. And then you're also using it for record keeping. So let's say your COVID vaccine certificates or university certification transcripts and the like. I like to think of these as the two sort of broad buckets that blockchain can be used for. I mean, we could add other functionalities like maybe identity management and possibly split out NFTs into its own category. So maybe that's something that I should look into. But at least for a lot of the stuff that I've worked on, this is the sort of thinking that I've taken with. And then the mechanics of a blockchain, also not going to go into this, but it was interesting to hear one of the groups talk about proof of work versus proof of stake, which are essentially like incentive mechanisms that are used to decide who gets to add information to the blockchain, in proof of work by solving a complex problem, and proof of stake by staking a certain amount of a crypto asset in order to participate in that consensus process. But also from the discussion that we've just had, it was nice to hear that the different teams have looked at, say, Tezos, Solana, Ethereum, and so forth. So the idea that there are already like different types of blockchain platforms is clearly not a foreign concept at this point. So as someone did say, Ethereum does have the most active community online and the most resources, most support resources to get going. So that generally makes it the de facto standard in terms of getting started with blockchain with blockchain technology. The problem is in its current form, because it's proof of work based, when there's generally let's say like a big event or something that takes over, some craze that takes over, the network will often become very congested, very slow, and the fees become ridiculously high for you to participate in the network. So whenever you're doing anything on the blockchain, whether you are sending money to someone, sending crypto assets to someone, sending value, or whether you are storing information, so let's say information like a university transcript, issuing a transcript, or even issuing an NFT or something, this generally happens in what is called a transaction. So you issue a transaction onto the blockchain, and then once it's validated, it's added onto the blockchain. Now the problem with Ethereum is once there's too much network activity and so forth, the price for the gas, which is the price that you pay to issue a transaction onto the network, that price generally will spike, and it can become insanely expensive to the point where low value transactions are not worthwhile, issuing on the network. So for example, I haven't checked recently what the sort of average transaction fees on the Ethereum network are. But I know at some point last year, if you wanted to, I think the sort of transaction fees are about $50 on average per transaction. So if you wanted to, for example, send $10 or $20 worth of Ether to someone on the Ethereum network, it did make sense that you're paying $50 in fees to send $20 in value. So collectively, you're paying about $70. So this is what generally then makes Ethereum, people consider Ethereum to be unsustainable if the prices remain high. There is a plan to move over from proof of work to proof of stake in Ethereum 2.0, and hopefully this will start to address some of these concerns with the gas prices. But that said, I think if of interest and if time permits, if any group wants to look into this, there is an alternative network that is called Polygon. It's considered to be like an Ethereum side chain. And what Polygon have done is they've created a blockchain network which is significantly cheaper than Ethereum. Any smart contract that you've written for the Ethereum network, the exact same logic will work on the Polygon network blockchain, and the fees are significantly cheaper. And the way that they do this is they're connected to the Ethereum blockchain, but they will only, for every, let's say, 10 or 15 transactions that happen on the Polygon network, they'll then roll these up they'll validate them on the Polygon network, and then they'll then roll them up into a single transaction that they write to the Ethereum blockchain. So that's how they sort of get lower fees. They have been getting quite a bit of traction in terms of applications being built on the Polygon network and so forth. So, this is definitely one option to look at, especially if like cost of transactions is your only concern within the Ethereum space, but you want to carry on within that Ethereum space, then the Polygon network is a network that I definitely recommend that you can take a look at, because whatever code you write for the Ethereum blockchain, it will work on the Polygon network. It's just a pity that I don't have their logo on this slide. But yeah, so you have different platforms: Ethereum, Tezos, Solana, Ripple, Stellar, Algorand, and so forth. And I think at the moment it's a bit, I mean, my personal opinion is that it's a bit hard to tell where the world is going. I think Bitcoin is sort of the de facto standard in terms of crypto assets. So I think they're here to stay. I also think that Ethereum, with its large following and community and so forth, is also probably here to stay. And then as for the others, I think time will tell eventually. So almost like with web browsers, and how eventually you go through a consolidation phase where you sort of maybe remain with 4 or 5 browsers. That's sort of my thinking about where this will go. But let's quickly jump into, well, one other thing that maybe is worth touching about Ethereum blockchain. Someone did mention transactions per second. Was this for Tezos or for Solana? I don't quite remember. Someone did mention this at the start.
I do believe it was for Solana.
Okay. Do you know off the top of your head what that number of transactions is? The TPS, transactions per second.
I wish I did. I'm sorry, I do not.
Okay, cool. So the Ethereum blockchain supports about 15 transactions per second, which is probably the second concern after like cost of transactions being high. So 15 transactions per second is rather low for like a global network. Again, I think when upgrades come to the network, this might increase, but that's probably one of the, if there's like 2 main disadvantages with Ethereum, it's going to be the cost of transactions and the low number of transactions that they support. But the ecosystem, in terms of the Ethereum ecosystem and what that looks like, you generally would write smart contracts, which are code that interfaces with the blockchain, and that you would write in Solidity, which is a specific language that looks almost like JavaScript. If you're developing locally on your local machine, you'd most likely use a framework called Ganache, which would be similar to other, if you can think about this the way you think about other web programming frameworks and so forth. And then you'd have MetaMask being your browser wallet, right? So in the blockchain space, a wallet is a user's space where you sort of keep track of which assets you have. So when I say assets, I'm referring to, let's say if you've got Ether, which is the native currency in Ethereum, you keep track of it in your MetaMask wallet to see the amounts. If you've got NFTs on the Ethereum network, you'd also be able to track your NFTs as assets within your MetaMask wallet. So this is kind of similar to the physical wallet that you would carry, where you might have your Standard Bank card or your FNB card and so forth. But the reason I'm sort of bringing this up is just so that at the back of our minds we can think about the concept of a wallet being how you track your assets and how you issue and sign transactions. Do we have a specific programming language for the blockchain? In the case of Ethereum, that's Solidity, and so forth. What does a smart contract look like? This is an example of what a Solidity smart contract would look like. So it's, if you're coming from maybe like a C# background or Java background, maybe this would sort of look a bit familiar to the syntax that is used there. I think it's a cross between JavaScript and maybe Java or C#. At least this is how I think about this. But the point here is that Ethereum smart contracts, you would have to write some extra code in an extra language that you're going to need to learn. Not difficult, but just something to think in mind in terms of how how much development effort you're going to need to put into this. Again, the reason I'm bringing this up is when we again talk about the Algorand blockchain, I'll sort of try and draw parallels to some of the technical bits under the hood. I've included here a link to a web application, an example, COVID vaccine register tracker, which is a web application where you can basically the idea is you'd enter in your ID number, your name, and when you've received a vaccine, and then that's added into a standard database, and then you click on Add to Blockchain. That then adds to the Ethereum blockchain. The link to that repository is here. And again, the idea for this is just so you can see what a basic example of an Ethereum smart contract in real life looks like, an Ethereum smart contract linked to a web application. And then from an architecture point of view, right? So for this web application, what would that architecture look like? You generally would have a user interface, which is the same as any other application you might be working on. You would have a web server or some backend with a database and all the usual bits. And then you then add a blockchain layer to it. This is one way of doing it, assuming that your application, for example, has its own SQL database or some other database, and then you also then connect into the blockchain. You could have applications that connect directly to the blockchain without any SQL database. So this is just one example of architecture that you could use. Again, this will have a similar one on the Algorand blockchain, which looks exactly the same, except that the blockchain layer, we're just considering the Algorand network. And I think this would be the same for any other blockchain platform you would look at. At least how I would recommend is you have a standard web application with a user interface, a backend, and then you integrate into the blockchain layer. And the main difference is whether you're integrating through a smart contract, which is the case in the Ethereum network, or whether you're integrating through an API or an SDK, which in the case of the Algorand network, you can do this through the SDK. Are there any sort of thoughts or questions that anybody has before we move on to the next section, just in case I'm going too fast?
So far, so good.
Okay. And the UCT students, anyone with any questions for now?
Sorry, I do just have one question in terms of
Yes.
I was the one who was a bit late. Apologies.
Okay. Yeah, sure.
So I just have a question in terms of, so I know that Solana, because like we're the team that's focused pretty heavily on Solana. So I know that it offers multiple APIs in terms of referencing the blockchain, and then you have the sort of Metaplex API that you can use to interact specifically with NFTs. But I'm struggling to sort of, in terms of just interacting with APIs overall, I'm sort of missing that knowledge there, right? So is that sort of scaffolding, basically you could build smart contracts, attach them to whatever you need to, and then move forward on your own site, or where are those smart contracts actually constructed?
Yeah, so that depends, I think, on the network. So in the case of the Ethereum blockchain, you are writing the actual smart contract, and then after you've written the contract, you have to deploy it onto the network, onto the blockchain network. So I've got an example here. I've got this link in the presentation text, so we'll be able to see that. I'll be able to share that afterwards. can you see my GitHub screen?
Yes.
Okay, perfect. So in this case, in the case of the Ethereum network, you would write the smart contract. So this is an example of the smart contract, the vaccine registry.sol. You would write the smart contract. Once you've written your smart contract, you would issue a command to deploy it onto the blockchain network. So you do this via the command line or something, or via your browser, but let's just say via the command line. And then you've got a configuration file which says which networks you would like to to deploy your smart contract to. So in the blockchain space, you've generally got at least 3 networks. You've got a development network, which is your computer that you're writing code on, assuming that you've got like a blockchain simulator of some sort. Then you generally will have a test net, which is a live network that's accessible from anywhere in the world, except the transactions there are not using real currency, right? So this will be a test network. So we could have a similar configuration here for a test network, and then you'll have what's called a main network or main net, and this is your live environment where transactions that are happening with that network are actual real value transactions. So if you were testing an application there and you're not sure if your application is working correctly, you could lose real funds, or you could lose real assets if you're testing NFTs, for example.
Okay.
So when you deploy the smart contract, you sort of specify, I want to deploy this contract to this network, right? So do you want to deploy it to the development network with mainnet or the testnet? But that's assuming that the network you're talking about, the blockchain network you're talking about, uses smart contracts, right? So not all blockchains use smart contracts. So if it's not using a smart contract and all you're using is an SDK, then you simply just need like a connection string, an identifier to say, how do I get access to this blockchain? And then whatever code you've written using, let's say JavaScript, if they've got a JavaScript SDK, that's just sufficient for you to interact with that network without doing a deployment.
All right.
Yeah.
Yeah. No, that makes sense.
Okay. Cool. So that's the Ethereum side of it. So let's move over to the Algorand side. So again, it's another type of blockchain network. The key differences are it supports at the moment about 1,000 transactions per second. So remember, the Ethereum blockchain is about 15 transactions per second. So if you're building an application where you think there will be high throughput, then you probably want to consider something that can support more transactions per second, which means that your network is less likely to become congested, if it's suddenly being used a lot. I haven't personally looked at Solana myself, at using the Solana blockchain, but the one thing that I've seen come up repeatedly, maybe 2 or 3 times in the last 4 months or so, is there's been cases where the network has gone down or has been unusable for a number of hours because of congestion. So I'm not sure if the team that's looking into Solana has come across this, or maybe you might want to take a look at this just to get a sense of why is that. So if there's anything that I know about Solana, it's this idea that people do question whether it is sustainable in the long run, given the number of times that it's gone down or it's been completely unusable when there's been a surge in network traffic. So that's something to look into. The second thing about the Algorand blockchain, it uses a proof of stake consensus mechanism. In fact, what they use is they call it a pure proof of stake consensus mechanism. And what that means is anyone wanting to participate in sort of deciding which block is going to be added to the blockchain, you have to stake some algos, right? So you stake a part of your wallet balance. So let's say in your wallet you've got let's just say 1,000 algos. You stake a proportion of that. For argument's sake, let's say you stake 100 algos. So it's about 10% of your wallet balance. So everybody who's staking some of the algos to participate in this, there's then a random, almost like a random lottery that then decides who's going to be the validator for the next round, right? Which is the next round being the addition of transactions to a block that's being added to the blockchain, and this sort of this random lottery takes into account the proportion that you have staked. So the idea is that if you hold a balance of, let's say, 1 million algos, and you stake 100,000 of those, that shouldn't make you more likely to be chosen as a validator as compared to someone who has staked 100 algos when their total balance is 1,000 algos. And that's because it's using the proportion, like what proportion of your total wallet balance have you staked, and not so much what amount have you staked. And that randomness just tries to bring in a sense of just adds to the security of the mechanism as well. The Algorand blockchain does also support the usual use cases of like NFTs. In the Algorand world, they're called Algorand standard assets, and the usual sort of finance, swapping, sending crypto assets and so forth. The nice thing about Algorand blockchain is that out of the box, you are able to issue transactions using programming languages you're familiar with, using the SDK that they provide. So you can do this, say, for example, using JavaScript or Python. Like those are the most popular SDKs, I believe, in the Algorand network. You can do this without writing smart contracts. Can you write smart contracts in Algorand? Yes, you can. But I would say for most use cases that I've come across, you can get away without having to write smart contracts. I found that the smart contracts are generally useful in applications where, how would I describe this? In applications where you are, applications that are, number one, like decentralized, right? So you've got people in different regions using this application, and you want to prove that let's say the data that you're using in your application, if this is an application for swapping between currencies, for example, you want to show that the exchange rates that you're using are not being manipulated in your code, but you're being fed into your system from like a trusted oracle. Then you can sort of start to think of smart contracts in Algorand. But my assumption is that for the projects that you're working on, you should be able to just use the Algorand SDK and not have to write smart contracts. So I'll just show you an example here. Let's just go back to this. So we're just going to look at this Ethereum smart contract. And the idea behind the smart contract is we're simply trying to store, this is a record keeping example, we're simply trying to store an identity number, a name, a vaccination ID, and details about when you're vaccinated. We want to store this onto the blockchain. But we have to write a smart contract, which is standalone, which is written in Solidity. You have to compile this, you have to deploy it, and so forth. In the case of the Algorand blockchain, all you would have to do is you'd have to use the Algorand SDK, which this is in the JavaScript space. You just have to write some code to import your SDK, and all of this is standard vanilla JavaScript. So I'm gonna go to the part where you actually write the data to the blockchain, and then this section here is an example of how you would be writing this data, which is the first name and the last name, to the Algorand blockchain, right? So if you're familiar with JavaScript, then all of what we're seeing here is vanilla JavaScript, except we just had to import the Algorand SDK the same way that you could import any other JavaScript library or SDK that you might be using for your application. So this is all you would have to do. In the case of the Ethereum world, you would have to write this smart contract. Over and above writing the smart contract in your main application, you then have to now make reference to your smart contract and the functions that are in your smart contract. So it's almost like, loosely, it's almost like there's like two steps involved. You first write your smart contract, then in your web application, you have to then make reference to your smart contract and the functions in your smart contract. Whereas if you're using the Algorand SDK, and this would be the same for any other blockchain that where the SDK allows you to do a lot without too much custom development. All you're going to do is in your application, you simply import the SDK and you issue a transaction using the language that you're already familiar with, which is JavaScript or Python or whatever it is. So that is in my view, it lowers the amount of overhead in terms of development, especially if you're trying to just do like a proof of concept or get going quickly and have something up and running quickly. Then a blockchain that has a powerful SDK helps you cut down on development time. So that's one of the differences. But again, it needs to be balanced against the context of, are you just concerned about time, development time? Are you just concerned about overhead in terms of like learning a new language, i.e. learning Solidity? Are you concerned about how much support you can find online? Are you concerned about the number of transactions per second that you want to support? Are you concerned about whether it's a proof of work blockchain or proof of stake blockchain? Those are some of like the considerations that you need to keep in mind. In the Algorand world, similar to the Ethereum space, you've got things like MyAlgo, which would be the equivalent of your MetaMask. So this would be a browser-based wallet within the Algorand space. You've got a transaction explorer, right? So this is called Goal Seeker. Transaction Explorer just basically allows you to see the transactions that have been issued by a specific account. Almost like the same way that you'd look at a bank statement and see all the transactions that have happened on your bank account. You can also see all the transactions that have happened either on a on an account that you own, or you can see transactions by searching using a transaction ID. This is not specific to Algorand Goal Seeker. The interface, or the developers of the interface, might be specific to Algorand, but the idea of a blockchain explorer to see transactions is applicable across all the blockchains. So same thing with Solana, same thing with Tezos and any other blockchain platform you come across. There will be a blockchain explorer that you can use to check for the transactions. Maybe one other thing just to mention, again, I spoke earlier about, there was a question about, how do you deploy a smart contract to a specific network? Each blockchain is going to have a main network, which is your production, and a test network, which is where you can do some testing and so forth. And then most of the newer blockchains, when I say newer, I mean at least post your Bitcoin and the Ethereum blockchains, most of these newer blockchains will have an SDK, which is a library that allows you to interact with that blockchain quickly and without having to write smart contracts most of the time. And in the case of the Algorand SDK, these are some of the links to that. And I think the last thing I just want to touch on is the architecture of an application, of a dApp, a decentralized application in Algorand. Again, similar to the one that I showed earlier, you typically have a web application with a backend server. This could be in C#, Java, or whatever language. You've got a UI, and then you've got the blockchain network in the background. And what you're using to connect to this network is the Algorand SDK, right? Where in the Ethereum blockchain, the difference is you're not so much using an SDK. You have to first write your smart contract, and then you're then connecting using one of these libraries like ethers.js or something. But the main difference, I guess, if I were to say, as developers or as a technical audience, one of the bigger differences is with the SDK, you can interact with the blockchain, you can issue transactions on the blockchain, you can create NFTs, assets, and so forth, using the SDK. So using whatever language you're comfortable with, as long as there's an SDK for that language. In this case, I assume JavaScript. So you can issue NFTs, issue transactions, interact with the blockchain, just writing JavaScript code because of the SDK, versus having to write custom contracts to do this. But again, I must stress that like in SDK, this is not unique to Algorand. Other blockchains will have this. So if you're also looking at other blockchains, look at the SDKs and how quickly you can interact with those blockchains. And then maybe the more from a business side, like the business sort of driving decisions would be if you want faster transactions, then Algorand could be an option because it's about 1,000 transactions per second versus Ethereum's 15 transactions per second. The cost of issuing a transaction on the Algorand blockchain at the moment, that is I think 0.0001 algos, 1,000th of an algo, which works out to using sort of present day valuations, this comes down to less than R1 to issue a transaction. So again, if you are supporting a large number of users, maybe this is a factor that you want cheaper transactions. And then I think one of the other comments was just around whether you want a proof of work or proof of stake consensus mechanism. You want something that's greener or energy friendly than a proof of stake blockchain, perhaps like Algorand would then be an option. So I've done a lot of talking. I think let me now like sort of try and tone it down, and then if there's anyone who's got any thoughts or comments or questions, this is a good time to shout.
Sorry, in terms of deployment, you mentioned that Polygon is very similar in terms of coding to Ethereum because it's a branch off essentially.
Yes, yeah.
How would the code differentiate Polygon from Ethereum? How would we actually do that in terms of the deployment of the code you've shown previously?
Cool. Yeah, it's a good question. Let's see if I can find this. So you sort of would define your networks in this truffle.config, where you sort of specify whether you're writing code in your local environment or onto the Ethereum network. So essentially, you would have something specific for the Polygon network. So it would be something like, I think your test net is called Mumbai. So you would have something called Mumbai, and then the connection details for Mumbai. Then when you issue the deployment command, you just would simply say, deploy this contract to the Mumbai network, and then that would deploy. I might have a code example for this. I'm not sure. Let me just check. So there's a project I'm working on where this food traceability project, we initially started out on the Ethereum network. And then we actually did move over to Polygon at some point. So you'll see here under networks, we've got a network called development, which is my local environment. We've got a network called DrinkB, which is an Ethereum test network. And then we've got a network called Mumbai, which is the Polygon test network, which this is the URL here for it. So when we deployed the smart contract to Polygon, it was just a matter of saying that I want to deploy the contract to Mumbai. And that's the nice thing was that this was the only change, because we already had the Ethereum smart contract, the Solidity smart contract. This was the only change we needed to make to deploy it to the Polygon network. Then once you deploy a contract to a network, this is in the case of Ethereum or Polygon, you get an address for that contract, which is like a unique ID for that contract. So in your code, you then just make reference to that unique ID whenever you want to interact with that contract.
Perfect. Thank you so much.
Sure. Yes, Meryl.
Yeah. So Julian, so there's a huge difference between kind of experience and skill levels with regard to blockchain amongst all the students. So, in your opinion, what's a good training? I'm trying to arrange Ethereum training via Consensus Academy. Is it worthwhile at least getting some Ethereum training, or should we rather not? Will that confuse the guys, or is it good to have some basic Ethereum knowledge just to understand how blockchains work? What's your suggestion around getting up to speed especially for maybe some of the students that haven't really been exposed to blockchain before?
Yeah, so Meryl, I would definitely say that if you can get some of the consensus training, that's I would recommend that, because the nice thing about going through the Ethereum stuff is once you've got an idea of let me just come back here. Once you've got an idea of the smart contracts, the right to Solidity, you've got an idea of MetaMask being the wallet, you've got an idea of like a development environment, a blockchain explorer and stuff. When you then move over to other blockchain networks, it's easy to make reference or to make these interconnections to say, okay, in the Ethereum world, we've got MetaMask. In the Algorand world, we've got something called MyAlgo. Like there is definitely value in learning Ethereum, I'd say.
Cool, thanks.
Yeah, Julian. Yeah, we appreciate the offer by Prof. Copier at UCT, how he can also provide some kind of coaches on Algorand. So do you have an idea how many potential technical coaches can be available for the students?
Yeah, I'm not too sure what their like day-to-day looks like, but I think it could be maybe about four or five mentors that potentially could come out of that. Yeah.
All right.
I do know that
excellent.
I do know one of the projects they're working on is an NFT related project. So that could also be useful. You know, there could be some useful resources or assistance in that regard from one of the guys there.
All right, no, thanks. Yeah, maybe I'm speaking for my group, my team, because we are the NFT group, and they're considering Solana. I think Max and your team, maybe you should take today and tomorrow before we meet to really look into possibly, if possibly, you can be able to switch into Algorand. I think that would be a plus, saving us time and cost, as well as the reason person who's also working on the NFT. I think that would be great, but I don't want to prescribe, but we'll discuss that on in our next meeting. Thanks.
Okay. Ravindran.
Thanks, Julian, for all your insights. It's been very helpful. Could we speak a little bit more about the development environment for Algorand? You mentioned Truffle and Solidity for Ethereum, but what is the equivalent for Algorand, or are they interoperable?
Yes, for Algorand, it's just a matter of installing the SDK and then just referencing that in your project. But again, this I can only speak to JavaScript, so Node.js project or a Python project. So the same way that you'd install, if you're familiar with Node.js, the same way that you'd install any package is how you'd install the Algorand SDK. So that would be npm install AlgoSDK, and then after that you can pretty much just use it in your JavaScript code. And same thing with Python. I think it would be something like a pip install or something like that.
Great, thank you.
Yeah. I think there's another hand that's up. I can't see whose hand that is.
Hi, it's my hand. I'm also one of those that came late, so I apologize for that.
Cool.
But my question was just with regards to the smart contracts with Algorand. I know that there are kind of two types of smart contracts. There are the stateful and then the stateless smart contracts. I'm not sure if this is a silly question, but I am kind of familiar with with the difference between the two, but if you could just explain that a bit more. And then a follow-on question is, do you only use one type of smart contract, like only a stateful, when deploying or when developing the dApp, or do you use them in combination, in conjunction?
Yeah, that's a good question. So it depends on the type of project that you're working on, whether you would have to like write a stateful smart contract or a stateless smart contract. But I purposely like avoided going down that road because I think the learning curve for smart contracts, like specific smart contracts within the Algorand space, is fairly steep. But 90% of the use cases that you're going to be looking at, you all you need to do is use the Algorand SDK. Like you actually wouldn't need to learn about stateful or stateless smart contracts. So when we moved over for one of the projects that I'm involved in, when we moved over from the Ethereum blockchain onto the Algorand blockchain, we spent maybe like a month looking at stateful and stateless smart contracts, only to then realize that what we needed to do, we could already just do out of the box using the SDK. So, for example, you can send and receive transactions using the SDK, right? So you can send algos, receive algos purely using the SDK without writing any smart contracts. You can issue NFTs, which are called Algorand standard assets, purely using the SDK without delving into like Algorand smart contracts. You can, the example application that I gave here, where if we wanted to issue these COVID vaccination records on the Algorand blockchain, we could do this with the SDK without having to write smart contracts. So yeah, for all intents and purposes, I'll say that like, yeah, the SDK should be sufficient for the level of projects that that you're probably looking at.
Okay, thank you.
Yeah.
May I just ask? Sorry, I think I'm just a bit confused with how Algorand then works. Just with NFT specifically, to the best of my knowledge, NFTs are typically minted through using smart contracts. So how does Algorand basically get around that? Just because I'm struggling to conceptualize that.
How can I answer this? Okay, let's go here. Okay, so the idea is, this is the vaccination record stuff. The idea is when you're writing stuff to the blockchain, you are, and especially if it's not necessarily like sending money, sending crypto assets from one person to the other, you kind of want to have a data structure about the kind of information that you want to keep. So in the Ethereum world, you would have to write a smart contract which defines what that data structure of the data you want to keep is, and over and above that, you then have to write the functions for adding that data, getting the number of entries in your data structure and so forth. So in the Solidity world, you would have to write a smart contract to do this. With some blockchain SDKs, like the Algorand blockchain, they sort of circumvent this by having almost like predefined functions within the SDK. So, for example, with the Algorand SDK, you can there's a command to send a transaction where you have a source, a destination, and the information that you want to accompany this transaction. And they then give you the flexibility to sort of define what that information looks like without needing a contract. So in the case of like NFTs, you've got standard pieces of information. For example, you've got the name of the NFT, you've got the ticker symbol for that NFT, right? So like what is a short name for this NFT, or if you're issuing your own like currency or an asset, like it will have a short name. So for example, let's just say the South African Rand, the short name is ZAR. So you're gonna have the name of the asset, the short name, what's commonly called the ticker symbol for that. You're going to have the quantity of this asset that you're trying to mint. You're going to have an address of who is initially holding all of these assets, or who is the person that's going to be receiving this asset. So you've got like standard information around an NFT, where before these SDKs came along, you had to define, if you were issuing an NFT in Ethereum, you would have to define specific fields to say, which information is relevant to this NFT. And then what then happened is, in the Ethereum world, they then came up with standards for different types of NFTs. So for example, you'll have standards for different types of tokens. So for NFTs, they came up with what they call the ERC721 token, I think, or ERC721 standard, which defined the information required for an NFT. So when these SDKs then came along, because the blockchain world had moved to these standards, it was easy for these SDKs to just sort of know what's in this standard and code that upfront, so that the developers like yourself or myself then don't have to redo this from scratch. This functionality is then provided by the SDK.
Brilliant. Thank you so much.
Yeah, I mean, what I can maybe do is I can include links to the ERC721 standard for NFTs, and then you just sort of see what the agreed template looks like.
That would be amazing. Please. Thank you so much.
Yeah. Cool. Is there anyone else, or Meryl, any other thoughts from your side?
No, I just I don't have any other questions, guys. Speak now or forever hold your peace. Kayla?
Hi, yes. Sorry to go back to the smart contracts, but I just wanted to ask specifically our project, which is the carbon credits trading system. And to my understanding, when issuing carbon credits, you do have to, there's a bunch of like protocols and requirements that are met, and that is kind of like a process. So even with that, would you still with kind of like the protocols and all the requirements included in issuing carbon credits, would you still not recommend using smart contracts, or would you say that the SDK is still sufficient and that wouldn't be required for this project?
I assume that the SDK should be sufficient, but maybe you can send me like an email with a spec or a high-level description of the project, and then I can take a look at it and share my thoughts. I assume that I assume that there would be some the credits would most likely be a token of some sort.
Okay.
Which sounds like so an NFT is a token. It's just not interchangeable. It's just not fungible.
Right.
You also do have fungible tokens, like tokens that, if I give you one token, you can pass it on to someone, and then you can then give me one token back at some point. But it's not. It doesn't matter if you give me one that's like different from the one I gave you. So if I give you 10 Rand now, and you give me a different 10 Rand note, like that's interchangeable. So I assume that those would be the credits that you'd use, and not so much NFTs, which are not like fungible in that sense.
Right.
And if that is the case, yeah, I think you'd just be able to still use Algorand standard assets, which are available through the SDK.
Okay. Thank you. Well, I will send an email just explaining or just giving a high-level overview. That would be really appreciated if you could look at that and just give your thoughts as well. So thank you for that.
Yeah, that's fine. See your hand? Yeah.
Just to pick up on what Kayla was saying, we for our project we also considered creating our own token that would be exchanged, or using Ethereum or maybe Algorand as the token as well, and kind of sort of having a conversion ratio between carbon credits and the token of our choice. Is that possible using Algorand?
Yes, that's possible. You can certainly you can certainly like swap between different types of assets, and these would be tracked in the user's wallet, in each user's wallet.
Okay, great. We will certainly send you a high-level overview of the project. Just as a follow-up, in your opinion, what front-end software do you think works really well with Algorand? Is it maybe Node.js or React, or any type of software that you've worked with that provides a good front-end solution?
Yeah, so the projects that I've worked on, we've used Node.js with just standard sort of HTML, EJS templating. You could use React, you could use Vue, or any other sort of front end that you're familiar with. Yeah, as long as I guess your data is accessible via an API, then you can use React or something.
Sure. Thank you so much. We'll be sure to send you that email. Thank you so much.
Yeah.
Julian, sorry, I just wanted to double check. So are you saying then you can actually create native tokens on top of Algorand?
Yes. Yeah. So
Okay.
you can have other assets on the Algorand blockchain. So the same way you can also do the same on the Ethereum blockchain. Yeah.
Okay. Cool. Okay. So yeah, I don't know if there are any other questions. One last question. Okay, looks like everyone's asked what they need to ask. I just wanted to say thank you so much for doing this. We really, really appreciate it. I think it's going to make the decision on which blockchain to use a lot simpler for many of the student groups. So we really appreciate it. Thank you so much. Akona, I don't know if there's anything you want to say from your side.
No, nothing more actually. Yeah, just to appreciate you, Julian. And yeah, if you want to talk more, possibly what else can we do? We can talk offline. Thanks a lot.
Okay.
Yeah.
Cool. Thanks.
Thanks so much.
Yes. So I think from my side, I'm hoping that this was at the right level and not too technical, maybe, if anyone does have like follow-up questions, you're welcome to shout. And maybe if I'm playing devil's advocate, I'd say that Polygon network for some of the teams that are maybe thinking about happy to go with Ethereum but want lower transaction costs, then the Polygon network is definitely worth considering.
Thanks, Julian. I think the issue is we kind of struggling to find technical mentors. So we'd rather, I think it's important for the students to think about, if they do get stuck, who do they ask for help? So,
okay.
Yeah, so I think that's as important. I mean, with bigger networks like Solana, etc., it's probably possible to just find the answer and make connections with Solana developers, but not as easy as actually having a group of people who are, starting to develop a lot of expertise close by you, which is what you guys are doing with Algorand. So, but I mean, it's really, we're not trying to put any pressure on any of the groups. I think each group needs to make their own decision, but you need to make sure you do your homework, look at the pros and cons, etc., etc. What I am going to continue doing is we've now got feedback from Consensus. So they will provide the training. I just need to provide some of the, I need to provide the names of all the students and then I'll give you access. I was just waiting for today's session to see, what the best way to go about this is, but I think it's useful anyway, getting some Ethereum expertise and to kind of really understand some of the concepts, because it then kind of makes it easier to then just move on to another blockchain because you already understand conceptually what you do. So
I agree with that.
Yeah. So I will send you the info as soon as I have it. Once they say you can go ahead with your IDs and passwords and things. Yeah. So thanks so much, and thanks for some of my other colleagues that have sat in on this meeting as well. Julian, it was way too technical for me, but I think it is at the right level for the rest of the audience. But and I kind of could understand some of the stuff, which